Welcome back. Let's do question 5.5. We are required to calculate the area of triangle ABC. This is a triangle ABC. Let me just join B and C so that we can have our triangle ABC. I'm going to show you three methods to solve this problem, but let's start with the first one. So the first method, we can divide this triangle into two triangles. Let me highlight the two triangles. We have triangle BDC, the green one, and then we have triangle ADC, the blue one. Triangle ADC. Right. These are the two triangles. Area of triangle ABC is equal to area of triangle BDC plus area of triangle ADC. Or the equation of the inverse of G is this, is equal to 1 over 2x minus 3. That was the equation of the inverse of G. And then from here we can say find the x-intercept, 1 over 2x minus 3. Then 3 is equal to 1 over 2x multiplied by 2 on both sides of the equation. 6 is equal to x. So the coordinates of C are 6, 0. Then the coordinates of D is the x-intercept of G. So 0 is equal to 2x plus 6. And then negative 6 is equal to 2x, meaning that negative 3 is equal to x. So the coordinates of D are negative 3, 0. Okay. So now DC, the length of DC is going to be 9 units, because from the origin to D, that's 3 units. And then from origin to C, that's 6 units. So 3 plus 6 is 9. Or you can use the distance formula. So DC is the base of triangle DBC. Remember from question 5.1, we managed to find that the coordinates of B 0, 6, meaning that the perpendicular height here from the origin to 6, that is 6 units. And then again this side, we managed to find the coordinates of A. In this question 5.3, we found that it's negative 6, negative 6, meaning that the perpendicular height of triangle ADC, the blue one, is what? Is 6 units also. Okay, it's a triangle like this, something like this. We have a triangle like this, and then remember the perpendicular height is outside like this. Okay, something like that. So the height is 6 units, the height is 6 units. Then the base for these two triangles is just the same. The base for the green triangle is DC. The base for the blue triangle is also DC. And DC is what? 9 units. So we can say, therefore, area of triangle ABC is equal to half times base. Base is 9, which is DC, times height, that is for the green triangle, which is 6. And then plus half times base for the blue triangle, which is 9 also. The base is DC. And then times height, which is 6 units. Right. Half times 6 is 3. 3 times 9 is 27. So it's 27 plus 27, which is meaning that the area is 54 units squared. That's the area there. That's the first method. Let's go to the second method. Right, second method, let's just write what we have. We have triangle ABC. The coordinates here is 0, 6. Here is 6, 0. There is negative 3, 0. Here is negative 6, negative 6. So what we can do here, we can use the area rule. We can use the area rule. Remember, g of x and its inverse, they are a reflection of each other about the line y is equal to x. y is equal to x is like the line of symmetry, meaning that AB is equal to AC. AB is equal to AC because of symmetry of G and its inverse. Okay, so AB is equal to AC, and then we found that AB is square root of 180, meaning that AC also is square root of 180. Okay, if we can find this angle here, if we can find this angle, which is the included angle, we can use the area rule. So according to the area rule, area of triangle ABC, area of triangle ABC is equal to half AB times AC, then sine BAC, which is this angle here, sine BAC. Right, we need to find this angle here. How can we do that? We can use the angle of inclination to find this angle, because we have the gradient of g of x. Remember, if we have the equation in the form f of x is equal to ax plus q, then a is the gradient. So we have the gradient here, we can find this angle. And then also we have the gradient for this one, because this one is g, it was like 1 over 2x minus 3. We have the gradient, which is 1 over 2. We can find this angle, which is vertically opposite to this angle. Right, and then with this angle, these two, this angle and this angle, we can find our angle BAC, because angle BDC is an exterior angle of a triangle. See, this triangle is like this. Let me just highlight. Now let's find this angle BDC. Right, angle BDC. So we're saying tan BDC is equal to 2. Then angle BDC is arctan, the inverse of tan, then 2. Then we get that it is 63,43 degrees. So this is 63,43 degrees. Then we can find this angle again, angle DCA, but we start by finding this one. All right, the gradient there is 1 over 2 tan DCA is equal to 1 over 2, because this angle and this angle are vertically opposite. So DCA is equal to arctan 1 over 2, which is equal to 26,57. 26,57. So this angle is 26,57, meaning that this angle also is 26,57. This one. Right. Now, if we add angle DAC and DCA, we must get angle BDC. Therefore, angle DAC is equal to 63,43, which is angle BDC, minus 26,57, which is angle DCA. Then we get what? We get 36,86 degrees. So this angle, this one, is 36,86 degrees. So we have our included angle. Now we can use the sine rule. Here is the exterior angle of triangle. That's the reason. And then now let's use our sine rule. This is our sine rule. So we're saying area of triangle ABC is equal to half, then AB square root of 180, AC square root of 180, and then sine 36,86 degrees. Then you can put this in the calculator. You'll get that the area is what? 53,9999 units squared, which is roughly 54 units squared. Remember, in the previous one we got 54 units squared. Okay, that's what you're supposed to do there. Then the last method. Let's do the last method. We have our coordinates 0, 6. We have 6, 0. We have -6, -6. We have -3, 0. Okay, we want to find the area of triangle ABC. So what we can do here is to find the length of BC, the length of BC. Okay, and then after finding the length of BC, that becomes the base of this whole triangle. This becomes the base of the triangle ABC. Now we need to find the perpendicular height. We need to find the perpendicular height, and remember that g of x and its inverse are reflected about the line, are reflections of each other about the line y is equal to x, meaning that this is the perpendicular height. This is the perpendicular height, this. So we need to find the perpendicular height, and then using our formula, area of a triangle is half times base times height, and then we get the area. The base is BC, so we need to find the perpendicular height. Right, remember we talked about AB and AC, we say they are equal, and then AB is square root of 180, and then AC is square root of 180. So we need to find this distance here, half of BC, half of BC. And then using half of BC and AC, we can find the perpendicular height using the Pythagoras theorem, because this is a right angle triangle. So half of BC and AC, we can find the perpendicular height because this is a right angle triangle. Let's find BC first. So BC is equal to XB minus XA squared plus YB minus YA squared. And then BC is equal to 0 minus 6 squared plus 6 minus 0 squared, which is 36 plus 36. So BC is the square root of 72. Okay, and then half of BC is equal to square root of 72 divided by 2. So now we have half of BC and AC. We can find the perpendicular height. Let's find the perpendicular height using Pythagoras theorem. So it's going to be AC squared, which is square root of 180 squared, half of BC squared, which is square root of 72 squared. And then this is the Pythagoras theorem. Pythagoras, right? And then therefore the perpendicular height is equal to, if you put this in the calculator, you must get 9 root 2. So the perpendicular height here is 9 root 2. We can use our formula for finding the area of a triangle. Therefore, area of triangle ABC is equal to half times BC. BC is the base, then times the perpendicular height. Okay, so it's going to be half times BC. We got our BC. BC is, this is BC, square root of 72. And then times the perpendicular height, which is 9 root 2. We got this one, 9 root 2, or here, 902. Half times base times height. Then put this in the calculator, you get your 54 units squared.